Kia ora Year 12. This is the second video on inverse trig functions and how to differentiate them. So the main audience for this is people doing the A-level Pure 3 exam, although people doing Scholarship Calc will also probably find this quite useful. And it's because my main target is the A-level paper that I've focused on these 4 questions, and I've made 3 of them about the inverse tan function, but I've chucked in an inverse sine for practice. So before we get going, I'm just going to go over the basic derivatives for the inverse trig functions, and then we're going to be using the chain rule over and over. I'm going to do the first question with a slow chain rule method using u equals 3x squared, but after that I'll switch to doing pretty fast chain rule. Okay, so let's look at the basics first. If we've got y is equal to inverse tan of x, then we can use this as a standard result now, right? So we did the proof in video 1, but now we're just going to be applying this. So we don't need to go and do all of that implicit differentiation every single time. So please don't waste your time on that, but make sure you understood it. So if it's inverse sine of x, then the derivative is 1 over root 1 minus x squared. And if it's inverse cosine of x, the derivative is negative 1 over this. I'm pretty sure that you don't get given those on the Scholarship Calculus formula sheet. So if you do think you might want to use them, you really need to memorize them, or you can just work them out from first principles every time. But they're pretty easy to learn, so I would commit all 3 of these to memory if you're serious about Scholarship Calc. Okay, so now let's go back to the first one and have a look at what we're going to do. Well, we're going to rewrite it as y equals tan inverse of u, and we'll let u equal 3x squared. So du by dx is equal to 6x. So dy by dx is equal to dy by du times du by dx, which is equal to 1 over 1 plus u squared. Right, so remember, here's y in terms of u here, times 6x. Now we substitute that back in, and we get 1 plus 3x squared times 6x. That gives me 6x over 1 plus 9x to the power of 4. Right, so we've done that one using u equals. I'm going to do that one again now, just doing it directly without writing out the chain rule the slow way. So I'm not going to write u equals anything, I'm just going to do it in my head now. It's a little bit like when you're working with binomial theorem problems, and this is especially if you're doing A-level again, and you know that you have to get your problem into the form 1 plus x to the power of n, right? So if, for example, you've got 1 plus x cubed to the power of n, then you just take this x cubed and you use this as the x block. So it feels a little bit like that to me when I do these problems. Right, so dy by dx will be equal to 1 over 1 plus the building block squared times the derivative of this function, which is 6x. So there you go, you can see we've got to that very, very easily now. We get 1 plus 9x to the power of 4. So now that I've shown you that method, I want you to pause the video and just try and blast through the next 3 questions before I do them in a minute. Okay, so question 2 was y equals 8 sine inverse of 4x cubed. So let's look at the derivative. Well, the 8's just a constant, so that gets multiplied through, so it's 8 times 1 over the square root of 1 minus this thing, the blob, squared, times the derivative of that inside function, which will be 12x squared. Cleaning that up gives me 96x squared over the square root of 1 minus 16x to the power of 6. Right, on to number 3. What was number 3? No, the next 2 are tan inverse ones. So question 3, y equals tan inverse of x cubed plus 1. So dy by dx will be 1 over 1 plus the blob squared times the derivative of this inside function, which is 3x squared. Now you could leave it like that, but it looks pretty awful. So let's expand this out a bit. We get 3x squared. Expanding this out and combining the constants gives me x to the power of 6 plus 2 x cubed plus 2. Right, one last one. As soon as you see that, you should be thinking about rewriting that with a fractional power. So dy by dx will be 1 over 1 plus the blob squared. So I'm going to write this out slowly. I know half of you are ignoring me and going straight to the answer, right? But we're going to have that squared, and then we have to times by the derivative of the inside function. So 3 over 2 x to the 1/2. Now this really needs a clean-up. We get 3 root x over 2, where are we? Is that right? 3 root x over 2 times 1 plus x cubed. Yes, that's right. I think that's right. If I have marked that up, I'm sure one of you is going to leave me a nice comment telling me I've made a mistake, but I think that's all right. I'm going to make a third video tonight, and that's on log differentiation, which is not the same as what we're doing here, but it's another great use of implicit and the chain rule, so that will be coming up soon after I've gone and done the dishes and cleaned up the kitchen.